In this discussion, we'll be talking about the scientific revolution of the 16th and 17th century in Europe. That began with the questioning of the old knowledge discovered in ancient times and through the Middle Ages in the Middle East and China and India, and brought about new knowledge about the world in Europe during this time period. Much of what was done during the scientific revolution owes to its origins in the ancient scientists of Greece and Rome and the Near East, rediscovered and questioned. Now, during the Middle Ages, Europeans were knowledgeable about some of the ancient scientists, particularly Aristotle, Galen, and Ptolemy, and their work was taken more or less as given fact, not sincerely questioned. But during the latter part of the Middle Ages and during the early modern period, many ancient texts were being rediscovered, including the scientific texts of other scientists from the ancient times. And with bringing in this new knowledge, people started to question it and look for new answers. He also had the influence of the Arab and Eastern sciences, which were very extensive and growing during the Middle Ages. The centers of science were in Baghdad and Cairo and other cities of the East, where they were making discoveries about optics and medicine and the physical sciences and such. And where we get our concepts of math from the Arabs and from India and other places. You also had the overall Renaissance spirit of questioning that had brought about greater skepticism that was now being put in place in the areas of the natural world. The scientific revolution began in Europe in the mid-16th century with the work of Nicholas Copernicus, a Polish priest. He began making observations of the heavens and developed the heliocentric theory, a sun-centered theory of the universe that went in opposition to the ancient work of Ptolemy, which argued for a earth-centered or geocentered universe. His work was followed upon by others who did the mathematics and additional observations. This included Tycho Brahe, Danish astronomer, who developed one of the first observatories and attempted a synthesis, of geo and heliocentric theory, where he believed that the Earth stayed still, but that the sun went around it, but that all the other planets went around the sun. He also had Johann Kepler, who developed the laws of planetary motion, discovering the positions of the planets and the relative speeds, and also part of that understanding that planets travel in ellipses, not perfect circles. One of the biggest impact was also Galileo Galilei, scientist of the early 17th century in Italy. Originally was going to be a doctor, but then switched to focusing on mathematics and the natural sciences, becomes a teacher, university lecturer. He questioned many ancient assertions, including the assertions of Aristotle, that falling objects fall at faster rates depending on their mass, which he disproved, showing that they fall at the same rate. He also supported Copernicus's heliocentric theory and looked at more and more evidence to prove it. And he had a new invention that had come from the Netherlands, the telescope, which had built upon work done by the Arabs and others in optics. And he used that to look at things like the moon, and noticed that it was not perfect, but marked with mountains and valleys and craters. Looked at Jupiter and saw its moons circling it. He looked at Venus and saw its phases as it circled the sun, helping to prove that heliocentric theory was indeed true. He, however, got into trouble with the church when he wrote his dialogue of the two chief world systems that directly supported the heliocentric theory, which the church had put a ban on. He was forced to recant his beliefs as a result. Arguably the greatest scientist of the scientific revolution, and perhaps the greatest scientist of all time, of course, was Sir Isaac Newton, who developed the laws of motion and related ideas of gravity, as well as the math of calculus and many other aspects of understanding optics and light. In his book, The Principia, he really set out the Newtonian world system that would dictate the understandings of physics from there on, and impacted many sciences, particularly physics, but all the other sciences and technological developments of the world after that.